Okay, y'all. I'm gonna go ahead and turn off these lights. Turn one off. Okay, that's how that's gonna be. I wanted to first address a few logistics things about this course. I'm very skeptical to close the door. I'm scared the glass will break. All right. For those of us who didn't join the lab, somebody casually opened the door and all of the glass broke out of the door on Monday. But a few logistics things about this class I wanted to address first. Okay, my voice isn't very loud. I'm sorry about that. There is, in fact, a microphone up here, but the person who knows how to operate this is on break this week. Great time, right when school comes back. So if the audio doesn't work again because of the mask and me not being very loud and what have you, I will re-record lecture like I did for this past week. Next, a few people asked me about the slides for future weeks. I've gone ahead and put the drafts of the next 3 weeks slides up on the course website for your perusal. Later this week, I will put week 6 through 10 up there, but they are drafts until class time. So I still have a lot of vetting all of the content of them for you all ahead of those days. But cool, that's done. Next thing was typically for the first 3 homeworks, I post an example of like an exemplary version of the homework that a student has done in a past year. You feel like that'll be a sufficient key for you all? Okay, I see some nods. That's what I'm gonna do. Next, don't struggle too much on a specific coding thing that you're doing. Like if it's taking you 10 minutes on one specific problem, go to the Slack, go to the mailing list, email your colleague, like do something about it. Don't just hit your head on the computer. Okay. Do we have any questions about those kinds of things? Great. All right, ggplot2. So this week, we're going to be talking about visualizing data, plotting, particularly through the package ggplot2. This is the graphics package underneath the tidyverse umbrella of our packages. Sure. So the question was, can I explain a little bit more about tidyverse? Tidyverse is attempting to make our coding more like Python or more like SQL by thinking about a structure where things read left to right and data gets piped toward your objectives in like a list format. And this is different than traditional R coding, which reads inside out. And that's why all of those nested functions I've been saying, like oh, we're gonna move past this, like, oh, this isn't the best practice. And tidyverse is also meant to, let's say, elucidate, to clarify a lot of things that are like just hard to read in our code. But it's a group of packages that are mostly put together by this New Zealander named Hadley Wickham. And it's maintained by these few other people. And it's just like a paradigm in R. First, I wanted to talk about some useful things before we get started specifically with talking about data visualization. One of which is comments. You may have noticed that sometimes I've written code and it looks like this. New.object, assign it the first 10 numbers 1 through 10. And then I put, hashtag making vector of 1 to 10. The pound symbol, the hashtag, is known as the commenting symbol in R. Anything written on the same line after a hashtag will not be run by R. This is incredibly useful for annotating your code and to remind yourself or others what you were doing in that section. Note that if it's not inside of a code chunk in an R markdown, this will produce a header. Trying to think what else. Question.
So if I were to write like a large paragraph of comments, how would it? Is there a way to do it so I'm not doing like the pound symbol for each line? If I can just do like pound symbol on line 1, text goes to line 4. Is there a way to make it so?
Yes, I follow what you're saying. I'll give you an example. So the question was, how do I comment like a block of text instead of just that line? So let's say I wanted to say, this class sucks. I don't want to be here. You could highlight all of it and hit Control-Shift-C, and that will comment all of that block. I'm sure there's another way to do it. That's the only way I know how. Comments are tremendously useful. I said for yourself, and part of that is I have code that I've written that's 4 years old, and when I return to it, I'm sure that these are very elegant solutions to the problems that I had, but I don't really remember how I got to the solutions. So keeping a comment that just says, then you took the log of this is really great. Highly recommend. Question?
Yeah, if tidyverse is trying to make it more like Python, are we gonna know by the end of this class what that really means? Because we're only using R, and I really don't know what that means.
Sure. I don't think that it will properly describe the connection to Python, and that it's only part of a comparison to another popular paradigm within Python called pandas. And I feel like it's a little bit outside of the scope of the class to explain all of the connection. About saving files. So you can save an R object on your computer as a file to open later. The method of doing this is the save function. And so you'll say save, and then the first argument will be the object. And then the next argument will say file equals, and wherever path to that object .r data. And that will save it as an R legible file. You can open up these saved files in R as well by using the load command and specifying the correct path to where it is. For that, and it will load just straight into your environment without you having to assign it to an object. Yes. You are making it the .r data. So like you type that to assign it that designation. I'm sorry, what was the last part again? It has to be .r data or I believe it's just .r data because it's saving them as an R object. I see. Yes, like this isn't the way that you would save a CSV or XLSS or something else. This is how you would save an R object that you've created to its own R legible file type called .r data. Yes.
So is this save to like directly save your documents? Is there a way to save it to a specific folder?
Sure. In that format, you could say something like save new.object file equals C users wherever you'd like it to go. Okay, so a little bit about where these files go if you don't specify a path that way. R saves files and looks for files to open in your current working directory. You can ask R what this is by saying get WD. If you run that command, they'll tell you where R currently believes that you are working out of. Similarly, you can set a working directory by specifying a file path to where you want R to be looking, so to speak. If you would like R to function more like you're used to working in a Explorer or Finder format, please read that Stack Overflow response. I do not highly recommend doing this, but if that's how you're comfortable dealing with files, go for it. Question? Yes.
That's like if you're working and then you forget where you're working from, so then you can it.
Right. Yes, it'll tell you what file path it believes you are working from. I would recommend going through the Explorer and finding the correct path. Right. If you wanted to, I would look up that Stack Overflow response, and that would help you. Another option that you would have is over here in your bottom right in the files pane. You can search through documents this way. Like here is our class, and here's where I keep our lectures, etc. But I find this to be a little bit confusing for me. One important caveat here is do not set a working directory in your R Markdown documents. Don't do it. R Markdown documents automatically set the directory that they are saved in as their working directory. Okay, about managing files. Yes.
If I try to like set my working directory and use this again, it's saying I cannot change working directory. You only set it.
No, I suspect that the reason that you can't change it is because you're working out of an R Markdown. You're not. Yeah, I'm sorry. I don't know off the top of my head.
Okay.
About managing files. When managing R projects, it is normally best to give each project, such as a homework assignment, its own folder. I use the following system. Every class or project has its own folder. Each assignment or task has a folder inside of that, which is the working directory for that particular item. A .rmd and a .r file are named clearly and completely. For example, this presentation is located and named this way. It's under my github.io/this class, lectures, week 2. Then I name it again, CSSS 508, week 2, ggplot2, .rmd. And doing this, I never really get confused about my files, what they're doing, or what's going on with them. You can use whatever system you want, but try to be consistent so that your projects are organized. You don't want to lose work by losing or overwriting files because you named them the same thing or what have you. Yes?
Yeah, sorry, I think I got a little turned around. How do you set the directory for online?
Yes, it's where you save your R Markdown.
Oh, got it. Okay.
For large projects containing many files, I recommend using RStudio's built-in project management system. It's found in the top right of the RStudio window. That's what this little ice cube looking thing is here. We'll talk a little bit more about how to use these, I think, in week 4. They're pretty nice, but I only use it when it's like a lot of files. For journal articles, I highly recommend Ben Marwick's R tools and Husky Down. For UW dissertations and theses, I didn't know about Husky Down when I wrote my master's thesis, and it would have made making a correct YAML and stuff for an R Markdown that looks correct for UW a lot easier. So look into that. There is a demonstration at that. A little bit about file types. We mainly work with 3 types of files in this class. That will be .rmd files. These are markdown syntax files where you write code that makes documents. .r files. These are R syntax files where you write code to process and analyze data without making an output document. And .html or .pdf. These are the output documents created when you knit a markdown document. Make sure you understand the difference between the uses of these file types, and please ask for clarification if needed. Okay, questions? Yes. I'd say the short of it is that a project file is a folder that contains many R objects that are R files that you're used to working with. Yes. Yes. I think it's right. Like if you, the HTML is really portable for this class. Like being able to pull it up inside of Canvas is really nice. But I'd say that most of the time when I use R Markdown, I make PDFs because everyone can open them up on their computer and they'll look the same. Whereas if I produce something in an HTML, there's a really good chance that it looks a little bit messy when it gets to somebody else's computer. Okay, before we get into data visualization even more, we need to talk about data and subsetting. First, for the homework, we'll be talking about the Gapminder data. We'll be working with data from Hans Rosling's Gapminder project. An excerpt of these data can be accessed through an R package called Gapminder. It is cleaned and assembled by the god, Jenny Bryan at UBC, just up the street in British Columbia. In the console, run install.packages Gapminder, and then load the package and data. Another thing about Jenny Bryan is she has, there's a link to one of her websites on our course website that's called like the things they didn't teach you in our class. And this talks a lot about file management and how the projects work and how to save things and best naming practices, etc. Highly recommend. Okay. Okay. The data frame we will work with is called Gapminder. Available once you've loaded the package. Let's see the structure of it using our wonderful structure function. Here, we'll notice it's a tibble. That is a data type that's also a data frame. We've got 1,704 rows and 6 columns. The columns are country, continent, year, life expectancy, population, and GDP per capita. What's interesting here that we can see from the structure, first we'll note that country and continent are factors, whereas year is an integer, life expectancy is a numeric, population is an integer, GDP per capita is also numeric. So what's going on with factors? What are factors? Factors are categorical data with an underlying numeric representation. We're all pretty used to thinking about factors when it comes to like dissatisfaction questions, but we just probably don't use the term factor at the time. We'll spend a lot more time on factors later. Like I said, N is 1,704. It has a nested or a hierarchical structure, which is that it's a year in a country that's in a continent. These are also panel data. So we have years, I think, between 1980 and 2007. Okay, about subsetting data. First, we're going to want to install the tidyverse. We'll want to be able to slice up this data into subsets. Things that are just the rows for Afghanistan, or think just the rows for 1997. We'll be using a package called dplyr to do this very neatly. dplyr is part of the tidyverse family of R packages that are the focus of this course. I also want to say, if you not already install tidyverse, this is the way you would do that. It takes a little bit to run. It's a lot to load all in. This will install a large number of R packages we'll use throughout the term, including dplyr. dplyr is a very useful and powerful package that we will talk a lot more about soon, like next week. But today we're just going to be using it to filter data. Okay, so loading dplyr. Note that I knit this document on my home computer where my R version's not as new. And so it provides this warning. This typically isn't a very big deal. It also says a few other things, including attaching the package. The following objects are masked from packages. What's going on with this error? When you load packages in R that have functions that share the same name as functions you already have loaded, the more recently loaded functions will overwrite the previous ones. So dblyr is giving you a notice that's saying, hey, I'm masking these functions that are just on your computer already. I'm trying to think of a very popular example that often runs over. If you are in a stats class and using the math package, I think that there's one that's called select that often gets overwritten by tidyverse. We'll see select soon. This message, it's not a warning, it's just a message, is letting you know that it's going to mask these things. To avoid that showing up in your R markdown file, say in your homework this week, add message equals false or include equals false to your chunk options when loading the package. Sometimes you may get a warning message when loading packages, usually because you aren't running the latest version of R. You can use the same chunk options to get rid of this warning, or you can just update R. Either way, no big deal. Okay, a little bit about magreader. This is a package also in the tidyverse, and pipes. So by loading dplyr, you are also loading magreader's pipe operator. That's what this goofy looking percent greater than percent object is, to pipe data between functions. So instead of nesting functions like this, like we have been doing this during the first week, where you would say, I want to get the log of the mean of the population column within the gapminder data. That's what this says. You would format it like this. You'd say, take the gapminder data, extract the population variable, and then give me the mean of that variable, and then take the log of that mean. So I read it already like that. So pipes read left to right, while nested functions read inside out. This might be a little bit confusing at first blush. We are going to continue covering this throughout the rest of the course. So to subset it, we can filter data frames by doing something like the gapminder data, and then we pipe filter country equals Algeria. And the resulting data frame will look like this. What's going on here? Go back to this one?
Yeah.
Okay, sure. So you read this as, take the gapminder data, extract the population column. So that's the $sign is the extract operator. Extract the population column, and then get the mean of the information in that column.
So what is it? Is that symbol of percent greater than that's called pipe?
That's a pipe, yes.
So that's just the operator that says like do the next thing on the next thing.
Yes, it's saying take the things from the left and then put it inside of the thing to the right. And then you can chain them together. It is a more legible way of doing it, in that if I get handed something like the top one, but it has 6 functions, it's very unclear to me how we got to that stage of the output. Whereas if we read the bottom one and it had 4 more things on the chain, it'd be a lot easier for me to understand, okay, we started with this data, and then we took the mean, and then we took the log, and then et cetera, et cetera. Right.
It's like a math equation, taking it out of the parentheses and then.
Yes. Yes. Right. We'll be covering more of this later. I just want to expose it to you right now and give you one example of how it works. Yes, question.
When you want to do that, you have to do library.
Yes.
First. So you like, if you're starting a document, would you just do like the top so that the following lines you can keep them?
Yes. Okay. So the way that we're able to filter down to just the Algeria rows is through a thing called logical expressions. And logical expressions just give you a true or false answer. So if we look at what country equals Algeria does, here's the first 50 elements of the Gapminder data. If we run country equals Algeria, and we'll see that for every row that is not Algeria in the country column, it will give a false. That's if it's not Algeria. Whereas if it is, it'll provide us a true. And what filter does is it says, okay, these things were true. We're only going to keep those things. Question. Mm-hmm. Mm-hmm.
How do you like change all the ways get all those?
There's a couple of ways. One, there's a percent and percent operator that we'll be covering a little bit today and later that lets you select on a bunch of different things as your logical operator or for your logical expression where Algeria is. There's another way through text methods that we'll be covering in week 8, I think, where you could write a regular expression, a regex, that will account for things that are slightly amiss in your text. Okay, so this returns a vector of true or false values. When using the subset operator, elements for which a true is given are returned, while those corresponding to a false are dropped. You might have seen this while tinkering around with your first homework. Note we used the equals for testing whether or not something equals to something else. One equals is not going to be enough to describe to R that you want a logical expression. There are many other logical operators. I'm going to go through them right now. You don't have to remember all of these. Just go back to the slide when you think you need a logical expression that does this. Okay, so exclamation point equals means not equal to. So if we were to say country not equal to Algeria, we would get every country in the Gapminder data except for Algeria. We have greater than or equal to, less than or equal to. I've already seen in some of your homeworks that you were trying this with numbers with like the fertility or agriculture, what have you. This is a logical operator. The percent and percent operator is used for checking whether or not something's equal to one or several values. So this would allow you to say, create a vector of countries. So Algeria and Albania and another A country, I'm sure, and check them all three of them at the same time. Or we can combine multiple logical expressions. The ampersand, the and, will allow you to select both or is when both conditions need to hold. The bar is an or. This is at least one condition needs to hold. The exclamation point just inverts a logical condition. So any true becomes false and any false becomes true. This maybe doesn't seem that useful right now, but there's a lot of times where you can think of a logical expression for the true thing, how you want to get rid of it, rather than make everything else true. You'll get there. Question? The and or the are? Sure. Or the and or the or the in specific? Yes. So we could say gapminder. Oops. Filter country equals Algeria, and PD or GDP per cap is greater than 1,000. So this would give me anytime Algeria is the country, and also in a different column that it's Algeria and their GDP per capita was above 1,000. Whereas if we used an or here, it would give us every time a country is Algeria and anytime a country has greater than 1,000 GDP per capita.
It prints out like in this line.
You just wanted to know the number of responses that you got there?
You could say that you're saying, like you're saying,
Right. Yes.
And so anything that might have been below the four becomes that's we'll have to go through and figure out all the number of
Sure. We're going to cover this more next week, but one method you could do is to do another pipe and just say maybe n row, and then it would just tell you how many trues you had. Question? For the example in the slides about the 12 rows.
So like just this example you're using.
Yes.
12 rows, but like, is that all the rows in the entire data set?
So like here, there are only 12 rows in all of the Gapminder data set for which the country is Algeria.
Oh, okay.
Yeah, and it dropped all the rest. Here is a multiple conditions example. I didn't remember that was the next slide, so I typed it out. So for this is country equals Oman, and year is above 1980. This will give me the rows where the country is Oman and the years after 1980. This was the OR example. So you can save a subset. If we think a particular subset will be used repeatedly, we can save it and give it a name like any other object. So we can, for instance, make an object called China, assign it the Gapminder data, and then filter to country equals China. And then if we look at the head of that, it'll just be all of the rows for which country equals China. And and it will be its own separate data frame.
Why do you need the original type of parentheses, greater parentheses, and kind of a filter in all these cases? Otherwise, we would have to nest it.
Yes. So I'm gonna okay, and so now you'll see in my environment, there is now a data frame that just has 12 observations, and it's just the ones for which the country is China.
Could you also do the logical operator percent in percent?
Sure. An example of that would just be some. Yeah, you would do it like this. It'd say Gapminder filter country percent in percent. Yes, because you need it to be a vector of elements. So you'd say Algeria and China, and it would now have 24 rows because it'll keep the ones that are just Algeria and the ones that are China. But we'll be covering more of that in the future. So ggplot2. I don't know about nerds sometimes. They'd just be making anything on the internet. But yo, what did 50 Cent say when his grandma made him a sweater for Christmas? G-Unit. I'm sorry. But this is Hadley Wickham down here, who I was talking about earlier, who put the tidyverse together. If you'll recall, there are base R plots from last week. This is how we could have made the Gapminder data or used our China data frame to make a scatter plot of life expectancy in China. This is how we would have done it using last week's plot functions. Sorry, did I see a hand? Okay. I want to talk about how we are going to move beyond doing things this way, because they're at least a little bit obscure and difficult to read. And we'd like to have a little bit more flexibility in the graphs that we make. An alternative way of plotting that many prefer, myself included, though this is not without debate. You can go to that link. You'll see people who don't like ggplot at all. Let's say there's a popular professor with his own graphics package that's in this department that also doesn't like ggplot at all. The core idea of this library, ggplot2, is a layered grammar of graphics, where we can break up elements of a plot into different pieces and then combine them together to produce a layered picture that looks really elegant and wonderful. So let's start with, we want to make a scatter plot of that same content we saw before. We would make a ggplot call. This is the function. We would then say data equals China, which is that data frame we made earlier, comma, AES, X equals year. This is going to be our X-axis. Y equals life expectancy. And then we are going to add a geom point. And that's how we're going to start with a scatter plot. I'm going to be talking through all of these elements as we build on them. You don't have to vigorously type this all down. The structure of a ggplot, ggplot2 graphics object, ggplot2 graphics objects consist of two primary components. First are layers, the components of a graph. We add layers to a ggplot2 object using the addition sign. This includes things like lines and shapes and text. The second component is aesthetics, which determine how the layers will appear. So we set aesthetics using arguments, so things like color equals red, inside of the layer functions. This includes locations on the graph, the different colors for each of the elements, the size of those elements. Aesthetics also determine how data map to appearances. Okay. Layers, our first component. These are things such as ggplot. This is the initial function that initializes the ggplot2 object and specifies the input data. There's geom_point, which is a layer that we would add on top to give it a scatter plot of points. geom_line would produce a layer of lines. ggtitle, xlab, and ylab functions are layers to add labels. There's also facet wrap. It's a layer that creates separate panels stratified by some factor, wrapping them around. There's also facet grid, which is a very similar idea, but can split two variables along rows and columns. So you could say facet grid on one set of plots, gender, and across a different axis, age groups. There's also themes that make it a lot easier to just get started with a ggplot, like theme black-white here, which replaces the default gray background with black and white. Layers are separated by an addition sign. For clarity, I usually put each layer on a new line unless it takes few or no arguments. This is things like the X labels, the Y-axis labels, or the theme. Our second component is the aesthetics. Aesthetics control the appearance of the layers. Aesthetics will take arguments like X and Y. These are the coordinate values that will show up on the graph. Colors, that's the color of elements based on some data value. Group describes which points are conceptually grouped together for the plot. This is often used when you want to make line plots. Size sets the size of points and lines based on some data value. Alpha sets the transparency based on some data value. A note about aesthetics. There are setting aesthetics and mapping aesthetics, and the language is really important here. Layers take arguments to control their appearance. Layers take arguments to control their appearance, such as point or line colors or transparency. Arguments like color, size, line type, shape, fill, and alpha can be used directly on the layers. This is setting aesthetics. This would be something like geom_point color equals red. You can see the ggplot2 documentation for options. Things like color equals red don't depend on the data that you're putting in it. Okay, so that would just make all of your dots red. Arguments inside an AES function call are mapping aesthetics and will depend on the data. So you could say geom_point aesthetics, color equals continent, and now each of your dots would be colored a different color based on the continent that they're from. So mapping aesthetics are based on the data, whereas setting aesthetics are global to your layer. Aesthetics in ggplot layers gives overall aesthetics to use in the other layers. So you can call aesthetics in the initial ggplot and not on the layer itself, and that will be global to your whole plot. If I'm saying a lot of words and you're like, I can't really keep up, we're about to see it in practice. It'll be okay. Okay. This may seem a little pedantic, but precise language makes searching for help a lot easier. So if you want to set something for all of your graph, or you want to map something based on the data you're putting in the graph, it's important to be specific. Now let's see all this jargon in action. Okay. So this was our base plot. If we just typed in ggplot, our function that initializes the plot, and set aesthetics x equals year and y equals life expectancy, this is what we'd get. A blank plot. Note that x and y are mapped to variables because they're within the AES column. Now, if we add a layer, the geom point, we will get a scatter plot based on the mapped aesthetics of the x equals year and y equals life expectancy. Or we could set the color or the size of the points. And this does not depend on the data. It just sets them on the graph. We can add an X label year to give it a capital Y. We can add a Y label life expectancy so that it's not just a raw variable name. And then we can add a GG title, life expectancy in China, to make sure people know what they're looking at. And lastly, we can add a theme and things will look a little bit nicer. Red on gray, I don't know so much. We can also, within our theme, set things like the text size, so it's a little bit more legible. Question? China's what now?
Like the air is like China now.
I see. Earlier, I ran this piece of code to create the China data frame. So we have a scatter plot that we like for our China data set. But what if we wanted to have all of the countries in the Gapminder data? If we just subbed out the data in that same code with the whole Gapminder data set, instead of just our subset of China, we would get this totally illegible plot. Maybe instead, we could just draw lines for each of the countries so that they connect the dots, right? But no, this would still be a mess. We can't just sub out geom line for, or geom point for geom line. In this instance, what we need to do is map group equals country so that ggplot knows that it's supposed to draw a line per country where along the x-axis is year and the y-axis is life expectancy. This looks a little bit more reasonable, but the lines are still too thick for sure. So we can remove the setting that we had of size equals 3 that made the red dots bigger. Next, we want to be able to highlight perhaps regional differences. So we can add a mapping aesthetic, color equals continent, that will group each of the continents into their own colors. The patterns are pretty clear already, thinking about historical inequalities with things like life expectancy. But what if we could just separate the continents completely? This is when we would want to add a facet wrap. Note the tilde here in the facet wrap call. I often think about this as the word by. So facet wrap by continent. Or if you'll remember in our original base R plots, we did life expectancy by year. I'm sorry? Right. Right, so we facet wrap by continent, and this will just sort of arbitrarily decide how many rows that you want, which if it's not a big deal to you, then it's okay when it just puts 3 on top and 2 on bottom. Facet grid allows more options when it comes to setting the rows and columns. We also noted that the text size had gotten too big here as all of the years are kind of stacking on top of each other. So we can remove our text size setting that we put inside of the theme. Perhaps we would want to bring that legend maybe underneath Asia and next to Oceania. One way that you can do this is by adding a theme layer. Excuse me. The theme layer is often where a lot of your nuanced or very focused things you want to change about a graph will be. So like if you're saying something about changing the text size, but only for some of your cases, you might want to start by Googling theme ggplot text size only some of my cases rather than just ggplot. Theme black and white will not accept a legend.position that moves this kind of thing, which is why I was trying to say the theme by itself is where you want to do a lot of your more focused and flexible things. You also want to add theme underneath a theme black and white or a theme minimal or a theme dark. And that's because the base themes like theme black and white will overwrite a plain theme that doesn't have black and white. One option that I think makes this graph look better is to just get rid of the legend. I think it's very clear that the colors are separated by the continents and the continents are separate from each other. Okay, about storing plots. We can assign a ggplot object to a name. So something like life expectancy by year, assignment operator. Note, I skipped to the next line here. I like the way it looks. You don't have to do that, but it helps me stay focused on what all is happening in my code. When you assign a ggplot to a new object, the graph won't display like in your viewer. You can show the graph using a single line of code with just the object name, or take the object and add more layers. So I'll give an example. So we created this life expectancy by year object. And then after we've created it, when we run the code that's just that line, that's just that object, it will show you the graph. Yes. Yes. So I could, for instance, right here, this creates the lines. Yes. So we run this, can't find function ggplot. I didn't run library ggplot. Okay, and you'll notice now that I have in my environment this object, but also my plot did not produce when I ran it, when I assigned it to the object. But now I can just run this line of code and it'll show me my plot. Okay, we're cool there. And you can add to that object that you've created another layer at the stage where it's just an object by itself. So like this. Okay, a bit about changing the axes. We can modify the axes in a variety of ways, such as you can change the X or Y range using the X limb or the Y limb layers. You can change to a logarithmic or a square root scale on either axes using things like scale X log 10 or scale Y square root. You can change where the major and minor breaks are using scale X continuous. Breaks equals, and then you'd add some vector there, or minor breaks and add some vector there. Here are a few examples. So you could say, make a ggplot with our aesthetics X equals year on our x-axis, Y equals GDP per capita, and make a geom line for it. And then we would add a scale Y log 10, where the breaks equals 1,000, 2,000, 3,000, 4,000, 5,000. And our labels, this scales here is a package that you might want to look into for your homework. It makes really tidy package or graph ticks so that it would automatically have this like $sign here and the correct decimal for cents, for instance. I also set the X limit to be 1940 to 2010, so it's a little bit wider than our data even show. But using that scale Y log 10 allows us to look at a log on one end. I think it does it evenly if you don't put breaks. Let's try. Let's make sure this runs. And if we don't put breaks, yeah, it gives its best guess about what kind of log you would like. Question? Scales. Yep, in quotes. Yes. The two colons in this sort of format, what this is saying is I don't want to necessarily run library scales at the top of my document, but I do want this function here, $. So tell R, look inside of the scales package, and then show me the $function without me having to write library scales anywhere in my code. So if you have it installed, but don't want to necessarily run it because you only want this one particular function, this is a really good way to get one function that you need. This is also the way if you have two packages where one is masking another function, if you want to run the one that's masked, that's how you would do that. Question? Yes, if you use the package name ::, you can pull out functions. And in fact, you can, it should tell you, like give you a drop down if you are in Markdown. So say like, I don't really remember the scales function that I need, but I know it starts with a D. This is like all of the functions that are in that package. Of course. Okay, we can change the text size from here. A note about text and tick adjustments. Text size, labels, tick marks, etc. can be messed with more precisely using arguments to the theme layer. Examples are plot.title. You would make an element text call, size equals rel2, hjust equals 0. This makes the title twice as big as usual and then left aligns it. You don't need to remember all of the stuff that's on here, but note this is how you would start to look for things like this. You could say axis.text.x equals element text angle equals 45 to rotate x-axis labels in case they all have long names, for instance. Axis.text equals element text color equals blue. Make the x and y axis labels blue. Also note that ggplot's not upset if you use U in the word color or summarize with an S, because it was originally written by Hadley Wickham, who's from New Zealand, and I think they use summarize with an S there. I don't know. Axis.ticks.length equals unit 1/2 in centimeters, makes the axis ticks longer. Note that theme is a different layer than theme gray or theme black and white, which you might also be using in a previous layer. See the ggplot2 documentation for details. I want to reiterate, use theme after theme black and white or other global themes, or else the theme black and white will overwrite stuff. Question?
So all of those examples, like plot title, those go inside the parentheses and theme?
Yes, they do.
And then to do more than one, you do a comma between them?
Yes, exactly right.
I'm sorry, can you just tell me what the difference between theme underscore PW and this theme is?
Yes, this theme lets you manually specify a bunch of things, whereas theme BW like decides for you a bunch of different options. It's just like a template. Scales. Scales for color, shape, etc. Scales are layers that control how the mapped aesthetics appear. You can modify these using scale underscore the aesthetic in question underscore the option that you want to change, parentheses. Layer, where aesthetic is either color, shape, line type, alpha, size, fill, etc. And the option is something like manual or continuous or discrete, depending on the nature of the variable that you want to change. Some examples would be scale, line type, manual. Manually specify the line type for each different value. So this would be things like when I was just reading a book today about changes in unionization in different countries. And Canada was done with a dotted line, and America was done with just a regular line, and OECD countries was done with a dashed line. This is what line type manual would be doing. Scale alpha continuous, varies transparency over a continuous range. So this would be like if you want dots to be not so bright, if they are be very faded, if the data is not that important, but if it's some sort of outlier, it would be very vibrant and bright. And scale color brewer is allows you to set palettes, and there's a list of palettes on colorbrewer2.org. Highly recommend. This is also a great place if you want to find differences between qualitative differences in your colors, or gradient differences in your colors, or colors that are colorblind friendly, et cetera, et cetera. When confused, Google or Stack Overflow it. Lots of great color resources. Question?
Yeah, how did you get the word spectral? Like when I go to that website, I don't really see the names of the palettes. Unless I make that up.
Huh. Let's find out. I don't recall now that I look at this. I'm very sorry. You can change the legend name, or this is an example of changing your legend name and manual colors. So in a layer called scale color manual, you would create these arguments. Name equals which continent are we looking at? Note this \n is a really old-timey way to put a line break inside of something. I don't know how to put line breaks inside of ggplot otherwise for things like the title. Also note that there's a question, there's a comma here before specifying another argument. And then we would say in a vector, values equals C, open parentheses, Africa, which is a value in our data, equals, and then what we want the value to take on in the legend. So equals C green, and then comma, Americas equals turquoise 1, comma, Asia equals royal blue, and so on and so on. Here's an example of a very fussy manual legend example code. There's a lot going on here. Note that there's two different geom line calls, and one of them is drawing a low S curve, which you'll hear more about from Chris Adolph when you take MLE. There's also a facet wrap to make the plot for each level of continent, and manual scales for size and color, custom labels, titles, and rotated x-axis text. I show you this mostly so that you can reference it again in case you're troubleshooting your own ggplots for your homework. But we'll go through it step by step. So we make a ggplot. The data is Gapminder. The aesthetics that we're mapping here are X equals year, Y equals life expectancy, and group equals country. We add a geom line. We add another geom line where the stat equals smooth, the method equals low S, which is like local regression curves. And the aesthetic for this geom line call, and not the other one, is group equals continent. Then we facet wrap by continent and say that we want 2 rows in specific, rather than just letting it willy-nilly decide for us. And then note in the scale color manual call, we say name equals life expectancy for values equals country equals black and continent equals blue. And this might seem a little bit weird. The reason that we're doing that is because the colors that can happen in our geom lines are on separate lines and in separate layers, but we want the legend to account for that. So that's why it is these values and not some others. The scale size manual is done very much the same way. In order to make the low S curve that we're probably more interested in for this particular question, really large, and the other ones really small. We add transparency, we add an alpha, and we set it to that particular geom line so that you can see all of the content underneath. We add theme minimal, and the Y label equals years, and the X lab, if you want an empty axis name in a really quick way, the best way is to add a layer like X lab, and then say that the title is just quotes with nothing inside of it. That's the quick and dirty way to do it. There are other ways that are more elegant, but you don't have to impress anybody. It's social science coding. Here is telling the graph that you don't want anything for the axis label, because it'll be clear to a reader that this is years. And then for our GG title, it actually can take more arguments than just the first one that is the title of the plot. You can also write subtitle. Here we've done that. And lastly, we've added a theme at the bottom. Note it's under theme minimal. X axis dot text dot x equals element text. And that'll take the argument angle equals 45 so that we can turn them all a little bit to the side for legibility. You can also include in that theme argument legend out position in order to scoot your legend underneath one of the plots. Question?
When you took away the X label, how come it's to years, those numbers?
It is the name year underneath the, like here, it says year underneath the plot. But when I add .xlab with nothing inside, it no longer says year at the bottom. I'm sorry? That's years in life expectancy. So that's why we wanted to get rid of it, because it says year and years. Yeah. Question in the back? How is it guiding it with those numbers?
Yeah,
I can't rightly tell you. I think it's between 0 and 1, and that, or it's between -1 and 1, and it's just, yes, it's just a gradient that you can move things through. I always have to look it up and mess with it every time. Okay. Okay. An observation. One could use filter to identify these countries with dips in the life expectancy and investigate. I leave that up to you as an option, as something that you could talk about in your homework. A little bit about customizing legends. You can move the legends around and flip their orientation or remove them altogether, et cetera, et cetera. The cookbook for our website is a really good resource for questions such as changing legends and labels. Highly recommend that text when it comes to things like, oh, well, I really want to have the log be at the bottom, but I want it to be described as a log, et cetera, et cetera. About saving ggplots. When you knit an R Markdown file, any plots you make are automatically saved into the figure folder in a .ping format. If you want to save another copy, perhaps of a different file type or use in a manuscript, you're going to use the ggsave function. And for this, ggsave will first take the file path and the file type that you want to save it as. Then you will specify what plot, which will be as a ggplot object. And then you can specify other things like the height and width of the plot and the units for which you're describing the height and width. If you don't manually set font sizes, these will usually come out at a reasonable size given the dimensions of the file that you output. So if you, for instance, said that you wanted a ggsaved plot that is, I don't know, 11 inches high and 15 inches wide, the text doesn't need to get moved up in order to respond to that size. It'll guess for you, trying to keep those same dimensions. There's also a bad and non-reproducible way to save your ggplots. And it's to go here and click export. And you can just say save as an image. And you can say, I want it about this big. And you can just name it however you want, or set the width here, or set which directory you want to save it to here. This isn't the best way to do it, but if your advisor's like, I don't really like your plot, can you change the axis label real quick? This is the best way to do it. For things like quick responses to emails, this is the way that I would do it. But if I want to save it and then send it to a journal, then I will ggsave it and make sure it's big and .tiff, for instance, so that they can read it legibly and manipulate the size to fit the journal parameters.
So all you have to do is change like the .pdf to PNG or whatever.
Yes.
It will know that that file name is that type of file.
Yes, it will. Book recommendation is Karen Healy's Data Visualization, A Practical Introduction. This book is really, really great. It's targeted to social scientists without technical backgrounds. It teaches really good visualization principles like the kinds that you would learn in Chris Adolph's visualization class. It uses R, the ggplot2 package, and the tidyverse. There's a free online version. It's pretty affordable in print, but I mean, it's a software. Just download that. Your homework. So you're going to pick some relationship to look at in the Gapminder data and write up a .rmd file investigating the question graphically. You might work with a subset of data, something like just countries on the African continent. Upload both the .rmd and the .html file to Canvas, and it should have these things. Include 4 to 8 plots. All titles, axes, and legends should be labeled clearly, so no raw variable names. You must have at least one graph with facet wrap or facet grid, and you must include at least one manually specified legend. You can use other geoms like histograms, bar charts, add vertical or horizontal lines. You may find this data visualization cheat sheet helpful. Your document should be pleasant for a peer to look at with some organization. You must write up your observations in words as well as showing graphs, and use chunk options like echo equals false to limit the code output you show in the .html. I also want to plug this cheat sheet for real. It has most of the things that you would want to do in a ggplot in 2 pages on a PDF. So it'll give you lots of different ideas about options that you have, because I really only talked about, geonline and geonpoint. But if you want to make, I don't know, heat maps or weird shapes, etc., this is all on here. Okay, let me write that down and I will see what I can do. At the top of the course website, I believe there's also a link to all of these kinds of cheat sheets that are in the Tidyverse, so that one will work. The PDF one's not accessible. Oh, that's right. My apologies. I will get that up probably tomorrow morning. Well, that's it for me, y'all. Unless you have any other questions. Sure.
So, you say explore relationships.
Mm-hmm.
It's been a while since I had a staff class, so I'm not very creative with
Right.
that. Is it okay to just take relationships that you like the kinds that you explored in the module today?
100%.
Okay.
Yeah, I'm not expecting you to talk anything about statistics. You could just say, like, I don't know, I have a friend from Azerbaijan. Let's see what's going on. Yes. Next week Tuesday. Next week Tuesday night. So it's just. Yes, you do.
Where do we do the number scale?
Just write it in the comment.
Oh,
Sorry, give me 1 second.